We already know that vectors are a quantity that has a direction. So anything that you can measure will have a magnitude, a size. And well, actually, not everything you measure, but most things you measure. I mean, technically, if you say what color is this, and I answer the question, then technically that's a measurement. But if I say what's the wavelength of this, then that would have a magnitude. What's the temperature? That has a magnitude. How much energy? How fast you're going? And how much time? All these things have a magnitude. So when I say the word magnitude, I mean size. I mean that's the number part, right? So how big is the number in my measurement? That's my magnitude. All measurements have magnitudes. Scalars and scalars have a magnitude, and so do vectors. The difference being is that vectors have a size as well. Sorry, vectors have a direction as well. So a force is a vector. So let's put example vector. And so the reason why the direction is important in this case is because if I said to you, we have two forces acting on an object, we have a force of 3 newtons and a force of 5 newtons. What is the resultant force? Without any more information, you might say, oh, it's 8 newtons. But of course, if it was one was going to the left and one was going to the right, it wouldn't be 8 newtons. It would be 2 newtons, right? So we've done about this already, and this is kind of like fairly basic stuff at this point. We've done this for a while. So we then went on to say, well, how can we add vectors that aren't along the same dimension? So this is along the sort of horizontal dimension. So how would we add vectors if it was going along 2 different dimensions? And we did an example of adding displacement. So imagine displacement's a great one to add because you can visualize it. So displacement is like direction. Displacement is like distance, but with the direction. So instead of saying I've traveled 5 meters, I could say I've traveled 5 meters north or traveled 3 meters east, right? So let's say that if we take these 2 examples, first of all, we're just going to do resultant of this, which is 2 newtons to the right. We're going to take these same numbers, the same dimension, and we're going to do it for displacement. So displacement, and we're going to go 5 meters to the right, and then we're going to go 3 meters to the left, and we're over here, aren't we? So in total, if we started off, and let's just zoom in on this, if we started off at that point there, and we've ended here, then altogether we have travelled from here to here, and the distance would have been 2 meters. So just like the case with the force, the resultant was 2. Of course, it's not the same unit because it's a different thing. We're measuring something different. The same thing applies, right? Does that make sense? So we've got, let's imagine now we take the displacement vector and we now add a different dimension in it. So now we're going to say we're traveling 5 meters to east, but we're going to go, instead of going 3 meters west, we're going to go 3 meters down. Now, if we said, well, what's the resultant displacement this time? Again, we do the same idea. We started from here and we ended here. Slight confusion here with the S meaning south, but it means start, and the E doesn't mean east, it means end. So, but if we were to measure this dimension, the length of this. If as long as we did it all to scale, right? If we actually really did walk 5 meters and we really did walk 3 meters, then the length that we have completely eventually gained, that would be the displacement. So you would work this length out using, well, what would we use to work out the length of that then? If we could use a ruler and just just measure how long it is, but if we didn't do that, then how would we do it otherwise? So to do it in this way, we want to use Pythagoras theorem. So we go, so to work, the displacement is going to be the square root of 5 squared plus 3 squared, which is going to equal to the square root of 25 plus 9, which is the square root of 36. Okay, square root of 36 is, so the square root of that would be 6. So the resultant displacement would be 6 meters. Now, in just the same way, so you can see with displacement, it just sort of makes sense, really. Of course, it would be 6 meters. Of course, that's how you would do it. What I'm saying is that you would use exactly the same method with all vectors. So if I take 5 newtons to the right and 3 newtons, well, we would do this. So in fact, I'm going to draw this and I'm going to group it. Okay, so let's say we've got that, and I'm going to group that one as well. So we've got this 5 Newton force and we've got this 3 Newton force, and let's say that we've got 2 people pulling at perpendicular and right angles to something on a post, for example, or on a tree. Right? Let's say they're both applying this force to something. What's going to be the resultant direction it's going to be moving? Or what is going to be the resultant force? It's going to be, and I should have really drawn it on the previous one, actually, the direction. I haven't actually done the direction itself, but it's going to be sort of that direction. We'll talk about how to calculate the direction in a moment. But to work out the magnitude of the force, it's going to be the same as it was before. We'd use exactly the same sum, and it'd be the square root of 25 plus 9, which is equal to 6. Obviously, this time it's newtons. Okay? So that's adding vectors. Does that make sense? Now, we're not going to, if we're using a bit of trigonometry, you might be able to realize that, we could probably work out the angle then as well, actually. So in fact, let me just briefly do that now. Actually, I will do that. So if we've got, we want to work out this angle here, what angle to that line is it moving? Well, this is a triangle, and it's got that's the angle there, theta. That's the opposite side. That's the adjacent side. So the tan of the angle is equal to the opposite over adjacent, which is equal to 3 over 5. And then to work out the actual angle, you would do the inverse tan of 3 over 5. Okay? I'm not going to go ahead and do that, but that's how you would do that. That's how you would work out the angle. What we wanted to get to, though, is what resolving vectors are. Let's imagine that resolving vectors is basically doing the opposite. So let's imagine we had a vector like this. Maybe this is a force, or maybe a velocity, or whatever. It could be many things. And what we want to know, let's say this is, let's take a velocity. So it's 10 meters per second, and it's 25 degrees to the horizontal. Now we want to know, could we potentially break this into 2 different vectors? So imagine this. So working out the different components of the force of the vector, in this case velocity, you'd say what 2 perpendicular vectors would add to produce this. So you essentially you can imagine drawing it into a triangle like this, where the hypotenuse is 10, the angle is 25, and I want to know what is this length here, which I can call, so let's say that is, the velocity is, so this would be Vx, the x component of the velocity, and this would be Vy, the y component, or vertical component of the velocity. Okay, so how would we work that out? So if we write SOHCAHTOA, TOA, I would always write it like this. I always teach my students to, and then I do it wrong. I write it like this. We don't actually need TOA for this case, so we're going to forget about that, but the same thing would apply. Let's just move it to one side. Let's move it over here. The reason why I write it like this is because it fits into a triangle. Oh, yeah. So let's put this into a triangle. The S stands for sine theta, the O stands for opposite, the H stands for hypotenuse. Same over here. The C stands for cos theta, the A stands for adjacent, the H stands for hypotenuse. So we've got, so on the left we have sine. In fact, we can just rearrange it straight away. We want to find, we look at our triangle, Vx is the adjacent to the angle. So Vx would be the adjacent. We've only got one triangle with the adjacent, so if we cover up the adjacent, it's equal to cos theta. Yeah, A is adjacent. So cos 25 in this case times 10. And then sine theta, or in fact opposite, which is going to be Vy, is equal to sine 25 times 10. So that would be how you'd work out the horizontal and the vertical components. Now, as I said, these are, and by the way, you can actually, you can do the horizontal, you can do perpendicular components. They don't have to be horizontal and vertical, okay? But usually they are. So these are what two perpendicular vectors would add up to produce 10 at 25 degrees to the horizontal. That's what these components mean. These are working out your horizontal component and your vertical component. Okay. So one example question, one that I often give, is let's say we've got a guy in a rocket going at 10 meters per second, and then we have his friend in a car underneath him, and he's trying to stay underneath him all the time. To stay underneath him all the time, he would have to travel at the same, his horizontal component of the velocity. You could imagine if you were flying above him even, then, and you only saw his horizontal motion, then the motion that you see is his horizontal component. You won't be able to see whether he's going up or down because of the perspective in which you are viewing his motion. Likewise, if you were alongside of him and you see him going away from you or going towards you, you wouldn't be able to see the forwards motion. You'd only be able to see the up and down. So we got the one guy, his friend, who's trying to stay directly below him all the time. He's going to be having his horizontal component. Then we've got, maybe I have to often say is this guy is in an elevator, and he's a sniper, and he's trying to take out this guy in a rocket. And he would, in order to stay at the same height as this person at all times, he would be having to travel at his vertical component. So he would be Vy, which we already worked out to be, and if we say that's the same angle, 25 degrees, Vy would be sine 25 times 10. And his friend would be going at cos 25 times 10. So that would be a sort of real life situation of how you'd be able to work that out. Okay.